All right, here we go with a definition-based question. You don't get many of these in physics, but you are expected to know for your electricity topic, for example, definitions of Ohm's law, as we'll do here, resistance, definitions of EMF, potential difference, current, etc. You never know when these are going to come. So have a look, and then we'll go for it. All right, we want to know a statement of Ohm's law, and this can come in various different forms, okay? So be careful. This is not, when we see the correct answer here, it's not the only version of Ohm's law. However, this is what the IB has chosen to do. They present it in a different way and see if you can pick out the right one. Okay, now when we're looking at Ohm's law, what I suggest is always a good idea is to think about what we mean by an ohmic conductor. An ohmic conductor has the following characteristic curve, which is a nice straight line through the origin. Now, what this means is that if we take the resistance of the ohmic conductor, we see R equal to V over I, then we end up with a constant resistance. So really what we're looking for is something about constant resistance. Okay. Now, before we go and look at the actual answer here, what I want to just remind students of is that there's a big misconception in physics, which is that Ohm's law is R equal V over I. No, R equal V over I is simply the definition of resistance. If you're ever asked to define resistance, you can use the equation R equals V over I. However, it is not a statement of Ohm's law. Okay, Ohm's law has a condition associated with it, and that is that the resistance, that ratio, is going to be constant provided we have constant temperatures. If the temperature is not constant, for example, if the temperature is increasing, there'll be increased vibrations of the lattice ions, and therefore those electrons are going to be impeded, and therefore that resistance is going to increase. Okay, so really when you're looking for Ohm's law and you're trying to define it and you're trying to state it, you really need to make sure you have that caveat that we have constant temperature, and therefore there's going to be a nice straight line through the origin. Hope that helps.